friends, welcome to the channel Base Your Btech. So let us begin a new course in this channel, which is Engineering Graphics. Here this is a technical drawing which describes an object in detail. That is, a 3D object is put into a 2D paper. Okay, it is 3D is converted to 2D figure, and we should get every details from that drawing. And many methods are there, like orthographic projection, perspective projection, many things. We will look one by one. First of all, orthographic projection. See, this is ground and this is your wall. I keep a table here. Okay, and a man is viewing this table, or let him have a torch lit. Okay, so what happens? The shadow of this table will be casted onto this wall, isn't it? See, if the man goes somewhat away from this point to here, and he does the same, he lit a torch and the shadow gets casted into some other point, isn't it? See, as the man keeps on moving and does the same thing, the shadow gets casted in different areas. That is, the table is projected to the wall in different ways. Like here it is the front view and this is a side view of the table, etc. So we are putting everything into a 2D plane, okay, 2D figure. By analyzing this particular figure or analyzing our orthographic projection, we should understand really what is happening in this room. Okay, so that is the aim which we have to hit for. So let me come to our subject now. That is the whole 3D space. I divide the whole 3D space into 4 quadrants. Okay, for that I need 2 planes, isn't it? 2 planes, when it is kept mutually perpendicular, I can divide the whole space into 4 quadrants. Quadrant number 1, 2, 3 and 4. And we can name this particular planes as, this is the horizontal plane HP and this is the vertical plane VP. Okay, and there will be an intersecting line. When 2 planes intersect, we get a line, isn't it? And we call it as XY. Okay, and with respect to this XY line only, we come to our conclusion. Okay, I mean, we have to draw this XY line first, and with reference to this line, we call this as reference line also, reference line or XY line. Anyway, this is the reference, and with respect to this reference line only, we come to many conclusions. Okay, as I just said in the previous example, that is the table must be kept in one of these 4 quadrants. Okay, so let us consider the table as our object, okay, and the man as our observer. Okay, and the plane or the wall we had is now our HP or VP. Okay, that is, we will place this table in one of these 4 quadrants and we will have an observer, and this observer will be casting the shadow of the table in one of these planes, if that is VP or HP. Okay, so actually this object we cannot draw a table and describe it, isn't it? So I represent this table or this object as a point object for now. Okay, a point object for now, and we will extend this thing as a line or then plane, solid, etc. Okay, first of all, let us have projection of points. The heading is projection of points. Projection of points. Okay, so our point, let us name the point as P. Okay, this is our point. So I am going to place this table or this point P in the first quadrant. Okay, I am placing this point in the first quadrant. So this is your P, and we must have an observer, right? I am not going to draw that man, but I am going to draw the eye of the observer. Okay, this is the eye. So while this observer is looking at this point, he is having a front view. Okay, front view. Front view means the observer is standing in front of the VP. That is front view. Okay, so this is the line of sight and it get casted onto this point. Okay, so P is casted onto VP and let us mark that point as P dash. Okay, small letter P dash. The object is capital P and the projection is small letter P dash. Okay, and when the observer is looking in this way, that is if it is a top view, I'll rub this. If the observer is looking the same point P in a top view angle, then what happens? This line of sight comes down and hit in the HP at point small letter P. Okay, so this is happening. That is, the observer is making two views. One is front view, another is a top view. Okay, and now we have to coordinate these two views and should be represented with respect to this XY line. So what is the criteria? First of all, definitely there will be a dimension saying about the position of P, isn't it? That is, this P is located like 20 mm, 20 millimeter above the HP, isn't it? P is located 20 millimeter above HP and P is located 15 millimeter in front of VP. Such kind of dimensions will be given. Okay, so we have to even mark this dimension also. I mean 15 and 20 has to be indicated in this diagram also. Okay, so let us start. First of all, we are going to mark the front view. Okay, that is the easy way. So let us mark front view. Okay, see, when the observer is having a front view, that means if the observer is in this position, he can view that this point is 20 mm above this XY line, isn't it? This P is above 20 mm above this XY line. So I can draw like I should take 20 mm above XY line and mark the point P. And what is the point name? It is P dash. So this is your front view. And now next we have to look for the top view. Okay, so when the observer is in this position, he can view this XY line beneath this VP, or VP and XY line are overlapped each other, isn't it? So this becomes the top of XY and this becomes the bottom of XY. So this observer understands that our point P is 15 mm below XY line. So he has to mark another 15 mm below XY line. And the point comes straight below this point P. Okay, this is small letter P because it is the top view, so it is coming below XY line because the observer is standing here and he is viewing this P below this XY line only. That is why I have marked small letter P beneath this XY line. Later on, you have to join this P dash and P. So this is the orthographic projection of point kept in first quadrant. Okay, but let me say that this method is somewhat harder because observer keeps on shifting his position, isn't it? So it becomes much more, I think it is confusing for you. So I will give you one alternative. That is, first of all, you should draw your XY line and you should mark your front view. Front view is easy because the observer needs to stand in one position only. Let him stand. So while viewing from here, he can see that the point is 20 mm away from 20 mm above the HP, isn't it? So it is 20 mm above HP and you can mark there as P dash. This is the same, but I said about having your top view is somewhat difficult. So what you need to do is, you just have to rotate this HP, okay? Because we need to spot out this point P, the small letter P onto this graph, isn't it? So you just need to rotate this HP 90 degree. Okay, 90 degree clockwise, 90 degree clockwise direction. So what happens? This figure, this plane would have aligned along this plane, or the HP is now rotated and came aligned with VP, and also this point P was on HP, isn't it? So this point will also have a shift there, and it is P. And you can see that this small letter P is having a distance of 15 millimeter from VP. Okay, so I can take this dimension here also, and now this is making a clockwise rotation. So this 15 comes beneath. So you can say that our point P or our top view is 15 millimeter below XY line. So from XY line, I make a 15 millimeter distance below XY line, and at that particular point, I am going to mark our top view. Okay, for front view we have to put P dash, and for top view we have to put simply small letter P. Later on you have to join this positions P dash and P. So this is your alternative method to draw your orthographic projection of point kept on the first quadrant. Okay, now let us move on to, so now let us place the point in the second quadrant and see for the orthographic projection. Okay, this is your VP and this is your HP. Okay, and here is your observer I, and let us place our point P, and let us have the distance also. This P is located, see this is your HP, right? So P is located about 25 mm above HP, and P is, here we have to say P is located about 15 mm behind VP, because with respect to the observer who is standing here, this P is behind VP, isn't it? It's in the back side of VP. So we have to say that P is located 15 millimeter behind VP. Okay, so now let us draw for the orthographic projection. So let us mark our XY first. We begin drawing with XY. Okay, XY is the reference line always. So this is your reference line XY. And what about the line of sight? The observer is looking at point P through this vertical plane, isn't it? Through this vertical plane. And the point where this line of sight hits VP, we call it as front view. Okay, so let this point be P dash, because for front view we have to name as P dash. Okay, and we can say that this P dash is placed 25 mm above XY. Okay, so 25, you should measure 25 mm and you should place the point P dash. Okay, now about top view. How to get the top view? You just need to rotate the HP to align with VP. So what happened? This complete HP will rotate and gets aligned with VP. So in this case, the casted point in the top view is about this position, isn't it? The vertical line that falls from point P to the HP is here. So while we rotate, what happens is this particular distance is getting upside of XY line, isn't it? We always make a clockwise rotation and for 90 degree. So this particular distance, which is about 15 mm, it's coming above XY line. Okay, so the while rotation, it turns about, so the position of point P will be somewhat here, and the length will be this 15 mm will be rotated, and this 15 mm will be coming over here also. This also will be your 15 mm. So we can say that above XY line we have to measure 15 mm again. So let this be the point, and here comes your P. So the orthographic projection is simply this line, P dash and P. Okay. Similarly, it goes for third quadrant also. Okay, now let's place the point on the third quadrant. Okay. This is your VP. This is your HP. Here goes your XY line. And your point P is located in the third quadrant, about it's about 30 mm below HP and 40 mm behind VP. Okay, here the observer is standing at this point. Okay, so the line of sight will be this line, and also the point of intersection of the line of sight and VP is here. So let us mark it as, if the point is P, this becomes your front view. Okay. And while drawing, see, this observer views this point P 30 mm below XY. So this time the front view is under XY. Okay, about 30 mm below your point P dash comes. Okay. Now let us mark the top view. For top view, again you have to rotate the HP 90 degrees so that it gets aligned with VP. So what happens? See, this time let us imagine if the observer is here, then the line of sight will be hitting at HP at this point, isn't it? If the observer is here, the line of sight will be hitting HP at this point, and this becomes the top view, isn't it? So let it be P itself, and while we move for a 90 degree clockwise rotation, this length which is 40 mm, this length which is 40 mm behind VP, when it gets rotated, this 40 mm comes over here, and your P location will be finally above XY line. So we have to take a 40 mm above XY line and you have to mark your top view. Okay. Now you please connect P and P dash. So this is the orthographic projection of point placed in third quadrant. Okay. And finally, see, I have kept a point in the fourth quadrant which is 30 mm below HP and 45 mm in front of VP. So let us draw. First we start with drawing XY line, which is the reference line, and when the observer is viewing this point, the line of sight is this, and line of sight hits vertical plane. This is your vertical plane, isn't it? The vertical plane, the line of sight hits the vertical plane in over here, and let it be P dash. Okay, so the observer says that the point P dash is located 30 mm below XY line. So please locate a point which is 30 mm below XY line, and here goes your P dash. Okay, and you can say that again about top view. Please understand that here, if the observer is viewing the same over this HP, the line of sight passes through HP at this point. So this is top view. So this is the top view. So let us mark it as small letter P. And when you go for a 90 degree clockwise rotation, this point turns and come beneath this XY, and which is 45 mm. 45 mm is rotated and coming beneath this XY line. So let us mark as 45 mm, and over this point you will have your P. So this is your orthographic projection for point kept at fourth quadrant. So friends, here is the conclusion. In the first quadrant, when we place an object in the first quadrant, the front view is above xy line, top view is below xy line, and when it is placed in second quadrant, both views will be above xy line. When it is in third quadrant, top view is above xy line and front view is below it. And lastly, when the object is placed in the fourth quadrant, you will get both the views under xy line. So that's all for today's class. Hope you got the idea of projection of points. And this is very important for your upcoming chapters in graphics. And if you got any doubts, please do comment below. If you like the session, please do like, share and subscribe the channel. Till we meet in the next class, this is Minu signing off. Thank you and take care.